You're on.
Good afternoon and welcome to this 8th episode of Knowledge Spectrum series organized by Krishna Sudha Academy. Uh, as part of Center for Sustainable Agriculture and in partnership with the Sri Padmavati Venkateswara Foundation, we are starting an academy on agroecology near Vijayawada. This is a 36 acres campus, which is going to be a learning center for all farming needs. So from agroecological approaches to developing farmers cooperatives and farmers business development to public policy issues in agriculture. So as a run-up to launching of this academy, which we are scheduling for end of August, we are also organizing several discussions on agroecological approaches across the country, the experiences we thought of bringing together, because we are at a very opportune time when the central government and state governments are looking for a change, both by compulsion with climate change and economic compulsion with the growing subsidies towards agroecological approaches. But at the same time, there are also several questions raised whether whether it is possible to make the transition towards organic and natural farming, and then particularly when we have to do it on a scale without much support from the state research and extension system. So that's a big question in front of many of us. Many people ask these questions always. So we thought we should also introduce to various experiences across the country. So we had experiences shared from Chhattisgarh, where the state government itself is trying out livelihood centers where they could bring in multiple livelihood activities at the village level and then promote agroecological approaches. And from various individual farmers and states, we are bringing in. And today we have Dr. Prashant Rajput. Dr. Prashant Rajput is a nephrologist from Global Hospital and also a very well-known organic and natural farmer. And we will be hearing from him about experiences on regenerative farming. And is one of those rare personalities where he could excel both in medical field and agriculture. So without much delay, I'll pass on the floor to Dr. Prashant Rajput. So, shall I enable you to share the screen?
Yeah. Perfect.
Yeah. Yes, sir.
Yeah, thank you very much, sir. I'm very happy that I can be here with you and discuss about regenerative farming and how was my regenerative journey in all these years. So basically, by training, I'm a nephrologist and more into transplantation of the kidneys at Global Hospitals Mumbai, and also have a farm in Jalgaon. And we also have a regenerative farmers group now, which involves about 500 acres of regenerative organic cultivation. I would like to give you the outline. I'll give you my background. We'll share some beginning stuff and how we had a transition into organic, regenerative organic from conventional agriculture. The regenerative practices which are there in our farm. Something about the soil health movement which we have started here, and at the same time we have started a regenerative organic farming movement, and some key take-home messages. Basically, it was in 2017 when I lost my father, who was into farming. So basically, I had an exposure to farming. We were at Jalgaon and we were cultivating bananas there. As we all know that Jalgaon is the banana bowl of India. And it was during that time, my father was into intensive conventional agriculture. And he was planting bananas since the late 60s. And he was the initial few people who actually brought drip irrigation into the country. We used to import drip irrigation from United States as early as 1989 or 1986 actually. So we started having drip irrigation for bananas. So in 2017, when I took over the land, with help of Dr. Patil, who's also my close relative, we had a tissue culture banana plantation. And I'm giving you this background to show how intensive practices are followed in banana. And we prepared the land. We used a lot of farmyard manure, about 5 tons per acre during that time. That was the standard practice while growing bananas in our part of Maharashtra. A lot of chemical fertilizers used as a basal dose. It was 150 kg of single superphosphate, which was used, one bag of urea, which is 50 kilos, and one MOP, and 10 kilograms of mixed micronutrient mixture. So this was the standard while we used to prepare a raised bed. And we had two laterals on each side of the plant, which was 2 LPH with a plastic mulch. Uh, in the beginning, the first year, I cultivated about 13,000 plants. And this was followed by intensive fertigation on starting from day 4, with 4 kilograms of urea and 2 kilograms of monoammonium phosphate, about 3.5 kilograms of muriate of potash on every 4th day for every 1,000 plants. So this was quite a lot. Fertigation, which includes micronutrients, ferrous, zinc, boron, and manganese every 15 days, calcium nitrate every 15 days. Though we did not have much issue with the pest, mainly the CMV, the bunchy top. We did not have any Sigatoga either. But there were certain practices which were followed, because of which we did not get. We did get flowering for the bananas at 4 months and 20 days, which was quite an early flowering. And once the fruit set was there, the nitrogen and the phosphorus was reduced. And we increased the MOP and SOP to 6 kg per every 1,000 plants. And our eventual dose was about 200 grams is to 75 is to 450 of NPK. We also did a complete fruit care from bud injection to floret removal to skirting bag. And eventually all this produce was exported to the Middle East and Africa. So this was my beginning. We also grow a lot of turmeric in our farm, and this was 15th of August 2017. I remember the date. And this was our summer plantation of turmeric, about 5 acres, which was our rotation with banana every year. So this was and this also included a lot of use of chemical fertilizers, a lot of fungicide use, a lot of use of pesticides. And this was the way we were farming. So when we looked at many papers which came around that year, and especially from reports from Canada, where there was a substantial increase in the gross expenditure, the input cost, and there was a reduction in the profitability. And this has been there in almost, though I was very wise to realize it within the first year itself. And I found that the current practices of conventional agriculture was ecologically not sustainable. It was economically also not viable, because if you see the amount of chemicals we were using, they were environmentally ruinous. Subsequently, during that time, I also used to do a lot of work for patients for chronic kidney disease. And I found that there was a significant increase in the number of patients having CKDU, which is CKDU of unknown origin. And the animal health also in that area was deteriorating. So this was a quote from Cho's Global Natural Farming. I went back to my teacher, and then we discussed about what best can be done. And then we decided that we'll move from the conventional agriculture to more of a perennial horticulture because of the time constraints. And seeing this, that was a time when we got in touch with certain growers from United States, and the regenerative ag was also in the was quite popular then, but not very, very popular. And we started following a lot of growers and their practices, and we discussed with our agronomy team. And that is how we transitioned into regenerative ag. So we started planning of the farm. We got the best engineers who were from Jain Irrigation, which is the company which is there in our hometown. We made sure that the whole piping and everything was perfect, and we laid the drip irrigation. You could see that during this time, we started the plantation. The first plantation was 8 acres of guava. You can see then was sweet orange, and you can see very clearly and distinctly that the soil was bare. And when we did the analysis of the soil, we had excess amount of phosphorus in our soil, a lot of potash in our soil, and the fertility measured with organic carbon was just 0.2%. This was immediately after the plantation, and what we did was we started covering the soil around the plants. So this was during the lockdown. The lockdown had just started, and we started growing a living root. You can see from this picture that we had sun hemp planted to create a microclimate. The temperatures were excess of 45 degrees, and there were limitations in doing any or planting any cover crops. So when this was our transition into regenerative ag, and the three core principles which we followed for our regenerative agriculture was to start producing healthy plants, and which were resistant to insect and pests. The second most principles which we thought was to produce nutritious food, and which means that once your plant is extremely healthy and it produces enough of proteins and lipids and the secondary metabolites, which then consumed would act as medicines, and we could at the same time produce an extremely high quality food. So this was the second. And third, the most important, was regenerating our soil when we were continuing to grow a crop. So this was the basis at which we started the principles, where we thought that soil health would improve plant health, and the eventually would improve the human health and the healthy ecosystem. So this was the premise on which we started the whole program. Our first and the foremost task was to improve the soil health. Certain regenerative practices which we started for our soil health was to start with no tillage in our farm. So our farm was not 100% at that time to begin with in the first few years, because we had intercropping. So it was very, very minimal tillage, maybe only once a year or so. From second year and third year onwards, we completely stopped the tillage. Having armored to our soil, we started learning about the concept of living root and the liquid carbon theory. We also started using our cover crops to improve the plant diversity. We also focused on the soil food web and improving the soil fertility with compost and compost tea. We integrated livestock in our plantation wherever it was possible. So when we look at the no tillage practices, we know that the invention of the plow, documented maybe a few thousand years before, fundamentally altered the balance between the soil production and the soil erosion. And this excessive tillage actually dramatically increased the soil erosion. Based on this, we made sure that we were not tilling, or even if we were tilling, we were having a significantly less tillage, so that we have significantly reduced disturbance of the soil, which were homes for our micro. Second was to reduce the soil erosion, because we know that the rate at which the topsoil formation occurs, it takes a few decades to form topsoil. The third was to improve soil infiltration, improve the carbon storage in the soil, and the most important was to have a better mycorrhizal fungi, which actually gets disrupted. And this is the main mechanism by which the immunity amongst plants is transferred. So once we reduced the tillage, what we could see was with the reduced tillage, we had a constant green cover over the farm, and there was the health of the plant was better. We had not even a single plant which had a wilting thing. We at the same time we tried to do a lot of stuff in this non-tillage farm, and we will go into details as we proceed. So this was a very elegant study which was reviewed by the European Commission. This was done in Germany, and what it showed was that tilling in farms reduced earthworm population by about 25% in 10 years as compared to lands which were not tilled. So this is the second thing which we followed was the soil armor, and we can see that whenever you have soil which is bare, it's going to, because of the microbial activity, it's going to lose carbon in the atmosphere. So all the time we had a dry mulch as well as the wet mulch always there on the bed, and not even a single inch of our land wherever possible was not exposed. So this was the banana which was elaki banana which we had planted, and the entire plant, even at 48 degrees Celsius, withstood that high temperatures during this season. And this was possible only because of the mulch. So the mulch, what we could see was this significantly reduced the water requirement. It improved the water holding capacity. We were measuring the soil temperatures during the midsummer. The atmospheric temperature was about 44 to 45 degrees averagely in the months of May this year, but the soil temperature remained less than 28 degrees. So this was, we have recorded all those events, and we could see that armor of the soil, not exposing the soil to direct sunlight, not only improves your the microbial habitat, it significantly reduces your evaporative losses of water, your water requirement reduces, as well as the soil temperature. So therefore, we did not have any plant. This was this banana. You can see this. This was at 48 degrees Celsius, and you could not see even the water stress in these plants. The third most important thing which we tried to do was having a living root near the plant, and so that and having cover crops as the living root. So this was during April of this month, where we had a mixed cover crop in our sweet orange plantation. Uh, this has a significant advantage, and the most important of this is it increases diversity. So this was a sun hemp, a mixed cover crop, which was planted. And the benefits of the cover crop is most importantly, this is a living root, and this continuously fixes carbon into the soil. So if you have to recarbonize the soil, or if you want to improve your carbonomics, we had a degraded landscape, and we used in these years when we were not cropping, we were adding cover crops to the soil, and over the 3 years we were able to increase the uh, the organic carbon of a soil from 1 to 3%, because if you see the amount of the root biomass which is added in a no-till system, it is extremely high, and we could actually improve the fertility of the soil. And this cover crops also helps to recycle nutrients. So all our cover crops, especially when we have the hemp planted, and along with this we have a cowpea, we have the uh, moong also, which is there, which is planted in this sorghum Sudan grass. So we inoculate this with the mycorrhiza and the rhizobium. And what we find is once these are terminated, you have a significant increase in the nutrition of the plants. So this not only improves the carbonization of the recarbonization of the soil, but it also helps to bring back fertility to the soil. The water cycle also improves. These are very important and fundamental ecosystem processes which are benefited while we add the cover crops to the soil. It also improves your soil structure and fertility. Your soil microbes significantly increases, and the biodiversity increases. So if you see this cover crops, which we usually plant in the, we actually use a lot of them. We use certain um, most of the time when we have compaction layers, we use carrots and radish. We use a lot of lucerne grass, alfalfa. Peas, we are use chickpeas we use, and we use a lot of sun hemp and daincha, which we have. So this is our cover crop mix, which we have recently planted. This was a cover mix for our monsoon. So this is a 7 crop mix. So we have 2 such cover crop sessions. Along with then we use weeds to as the cover crop. So this is how we are terminating our cover crop, and so this is averagely about 5 liters. So this is our banana plantation, where we plant sun hemp, uh, and with this uh, cover crop, it also helps to improve the microclimate, and eventually this would also be terminated into the system. And this significantly not only adds carbon to the soil, it cools down the temperature. This is at this is an April plantation at 46 degrees Celsius, and you have a significant improvement in the survival of these crops. I would then like to take you to why we need these cover crops. And the most important thing when we look at the geological processes which are happening in the soil, the greatest geological force is life itself. So this is a rock which is broken in two pieces by the root of the tree. So this is the force which the life can get, and this is because the roots have a tremendous capacity to get nutrients, and this is through the very important process which is photosynthesis. And the whole theory of this which improves your soil fertility, it is called as the liquid carbon theory, and the primary process which drives it is photosynthesis. We all know that what is the process of photosynthesis. It's very simple. We have been taught from standard 4 onwards that carbon dioxide and water in presence of sunlight in a plant cell, which is the chloroplast, where the chlorophyll is stored, the sugars are produced, C6H12O6, and the oxygen is liberated. So this is a very primary process, and every farmer knows this process, that how the photosynthesis is produced. So this is the primary driver, where you're taking up the atmospheric carbon and producing sugar. So what happens to these sugars is very important. So before we proceed, we need to know how to optimize photosynthesis. The most important is the nutrients which are there in the chlorophyll molecule. So it's very important to make sure that these nutrients are present, and there should be no deficiency of these nutrients when the plant is actively growing. Looking in for these mineral deficiencies is extremely important. So if you have a magnesium deficiency, obviously that would be shown on the leaves. Nitrogen, iron, manganese, and phosphorus, all this is shown. The scouting becomes extremely important. And we have our own mixes, which a micronutrient mix, which we have developed, an organic micronutrient mix using fish amino acid, where we spray on these plants and make sure that our photosynthesis is optimized. The most important is the magnesium and the nitrogen, which is the key part in the chlorophyll molecule. The other important is the manganese, and there are very limited publications on this, where it has not been really taught that manganese is extremely important in water hydrolysis, and iron in the electron transport, and obviously phosphorus in generation of ATP, which is required during this process. So it is the photosynthesis which is responsible for how much amount of carbon you're going to add in the soil, how you're going to recarbonize the soil. So if your photosynthesis capacity is suboptimal, that means it is functioning only at 20%. Say you're producing a kilogram of sugars per day during this process. So 30%, 35% of your sugar produced is going into the formation of the plant biomass, and 35% in the fruit or grain which the plant is producing. 15% of these sugars go in the production of the root biomass, and another 15% as root exudates. So 70% of the sugar, that means almost 700 grams, remain above the soil, and about 30 grams is going into the soil in form of root biomass and root exudates. When we increase the photosynthetic capacity, so this is very important for all our farmers to know, that if your photosynthetic capacity improves to about say 60%, then your amount of sugar produced is about 3 kilograms per day. And now your distribution of sugar is completely different. So you are going to add about 50% above the ground as a root, as a plant biomass, and stored in form of fruit or grain, and 50% of your carbon is going to go below the ground. So about 1.5 kg. Though what we emphasize is on the plant having a complete photosynthesis. This root exudates, it is gromelin, which is produced by the bacteria, and it is in form of certain amino acids: glycine, valine, isoleucine, leucine, methionine, arginine. So now we have all understood the importance of amino acid signaling in mineral nutrition in plants, and we have been using these amino acids produced in regenerative ways to improve our mineral nutrition in our plants. And the other is free fatty acid. So this is a root, a structure of the root which is exudating the gromelin from the root, and this is taken up by the bacteria, and they use this gromelin, fructose, sucrose, even glucose as the source, and it multiplies. Fungus takes this gromelin and sucrose and fructose and converts this into trihexylose and stores it. So what happens during the peak photosynthesis is you produce sugars, the sugar is transported. If you have a deficiency of molybdenum or the boron or calcium, your amount of sugar transport significantly is less, and the conversion of the sugar into proteins, lipids, and secondary metabolites is very, very minuscule. So this is very, very important to know that your plant, which is there planted in the farm, is optimally photosynthesizing. So when we look at the concept of soil armor and why you need a living root, so whenever you have a tilled soil or a soil which is not covered with either a living root or a mulch, you are going to lose water, you're going to lose CO2 in form of methane. If your soil is covered with a living or plant, that is going to fix the water into the soil, the CO2 into the soil, and this is going to have a major ecological impact. And therefore, it's very, very important to have a living root and a functional soil food web, which is the microbial life in the soil. When we look at the soil food web, what we most important is to have a plant which is a living plant. And this living plant, when it is terminated or when it is mulched, it produces organic matter. And this organic matter is taken up by our root exudates, feed the microbes, mainly the bacteria, and about a few million species of fungi, and you have root feeding nematodes. So these bacteria are further taken up by the protozoa, the nematodes, and the arthropods, and this whole soil food web up to the fifth, which is the highest tropic levels of predators. They work in tandem in the soil. The most important of this for the plant nutrition is these organisms, the bacteria, the fungi. Bacterial causes demineralization of the soil. It is known to produce organic acids. Fungus is known to produce organic acids and certain enzymes, which are mainly produced by the saprophytic fungi and even mycorrhizal fungi. They have storage of major nutrients and major carbon storage, and fungi can be so enormous that they themselves can be in terms of surface area a few kilometers long hyphae in just a teaspoonful of soil. So bacteria and fungi are the primary organisms in the soil, followed by nematodes. And these bacteria and fungi are eaten up by protozoa and nematodes. And these, once the bacteria is digested and the poop of these protozoa they are actually a plant available form of nutrients which are taken up by the plants. Arthropods, microarthropods, nematodes, which are predatory nematodes, they also help in recycling the nutrients to the plants. And it is these organisms, if you have a 100% bacterially dominated soil and no other organism, you're not going to have a substantial amount of nutrition to these plants. When we look at biodiversity, it is very, very important that we should minimize use of the fungicide. Funguses are extremely important and the most magnificent creatures on this earth. There are about 6 million species, and we are not able to, we have only studied 350 of them. So it's very, very important that the fungus, you can see this mulch which we had covered. The black fungus, you can see, this is the Aspergillus niger. And it's a very, very important fungus as far as the disease suppression in the plant is concerned or in the soil is concerned. This is also the fungal adds digest these pectin and cellulose in the high carbon, and it stores carbon in form of trihexocellulose in its hyphae, and it remains and this then eventually gets converted into humus, which can remain in the soil for decades, and it is the key driver for soil fertility. When you look at biodiversity in this our soil, what has happened is for every square inch of soil, because of the ample organic matter available and the functional soil food web which we have, every square inch has about 3 earthworms, and this is one of the key indicators of soil fertility. We have the pollinators in sufficient quantity because we have never sprayed our farms with any harmful pesticides and herbicides till date. When we look at other arthropods, ants play an important role in disease suppression and nutrient cycling, the geochemical nutrient cycling. Ants play an important role in the ecosystem. So this is our, basically this is our, it's a sitafal plantation along with moringa. It's a syntropic forest which we have created. And you can see that the amount of biomass which we add each year in the soil, and the soil, the rate at which the soil recarbonizes is extremely high. So this is a 4-acre farm where we use the moringa as a syntropy in our custard apple plantation. To improve soil fertility, we have various techniques. We use bioculture, and this is a Jivamrit slurry which we produce. We produce about 25,000 liters of Jivamrit. We have about 16,000 liters of compost tea which we produce, and this biology is added to the soil every week. So this is a huge amount of fertility which we are adding to the soil. Compost, we are using Trichoderma as our composting, along with certain Metarhizium species and certain saprophytic fungi. And what we try to do is we bioculture this compost in the NADEP composting method, and we broadcast this compost 2 to 3 times a year in the farm. We are using a lot of biocultures and bioherbicides and pesticides, biopesticides produced in the farm. So this is about 7,000 liters, 4,500, and this is about 3,500 different forms of biocultures using the NPK consortia, the Acetobacter, then we have Pseudomonas and Bacillus subtilis. Then we have certain products produced by the Korean natural farming, that is JMS, and the indigenous microorganisms, IMO, which we produce, and we put this back into the farm. So this is, we produce fish amino acid as the source of nitrogen and phosphorus. We have the uh, fermented fruit extracts, which we produce as a source of potassium. We make neem-based and dashparni are neem-based biopesticides. And basically, they are repellents and bioherbicides, basically biopesticides for repelling using dashparni. So this is our uh, vermicomposting methods, all animal based. We usually vermicompost in our bed. This is a regenerative organic farming group which we have started in our farm, and here we are constantly producing almost 50 to 100 tons of vermicompost each year, and we are distributing this to farmers at a very economical rate in our vicinity. When we also use biochar, so this is the biochar, which is also a very rich carbon source. It helps in adsorption of certain toxins which are produced by certain fungi, and it also is a carbon source, and it helps to improve fertility of the soil. Livestock integration, which we have done, and mainly in our regenerative system, we are integrating the livestock here. They are free grazing cows, and what we have seen is the weeds have been now replaced with grasses, and we have no more weeds now. The grasses which were there in the our forest have now come back to life, and we have integrated our this is our 8-acre guava plantation where we have integrated cows, and this is primarily the what the cows are doing is they are recycling nutrients, they're trampling the grasses, they're eating, they're adding fertility in form of dung, and the most important is their cow saliva, which transmit the microbiome of the uh, uh, this livestock gut into the and this restores the what is called as the holobiont of the soil. So in nature, it's very important that the currency uh, is life. So we need to have life in the soil in form of microbes, in form of livestock, which helps to improve the soil. And then what we have is we start producing nutrient dense food. So this is our intercropping of uh, your sweet orange with elaki bananas, and we have about 500 odd plants, and this is the uh, elaki or puvan. This is a puvan banana which we have planted, and then we have a red banana. Basically, this is not a part of our ecosystem, but we have planted it, and they have grown really well. Then intercropping, we do a lot of spices like chili and garlic, and which we produce the chili powder. We have sweet orange plantations. We have papaya. We have moringa. We sell moringa leaves, moringa pods, and as well as the moringa seeds. And these are completely free. They taste uh, which is completely different. It has significantly impacted hundreds and hundreds of patients who are people who are consuming this. So we have our turmeric plantation. We have our own branding of turmeric. We have sold this turmeric into more than 30 countries now. And this is a syntropic system, and this is completely free of chemicals and pesticides and herbicides. So this is a syntropic farm where we have four crops. We have an aromatic herb, we have sweet orange, we have ginger, and we have cowpea. And we sell this ginger in 4 cities now. So very important is it's not that what we are doing, we try to train farmers at our farm. So we train farmers from across Maharashtra, and we teach them about the regenerative organic system. We also work closely with the government, especially our Dr. Bokre, who was the regional director in the Department of Agriculture in our place. And we have bureaucrats also visiting our farm and learning these processes. We conduct workshops for people who are interested, for agriculture people, doctors, certain scientists of KVKs, and we have a lot of training given to farmers from across the states, where we teach about organic farming. We conduct workshops, and these are workshops which we have recently done in the last year, where we have taught more than 20,000 farmers through our workshops. We have now formed a group of few farmers who are adopting all our practices, and we are producing crops and growing crops in about 500 acres of land in my village. So this is what we have transitioned into. We were a monoculture, and this we have now converted all this monoculture into a syntropic regenerative organic system, where we have multiple crops, and we harvest almost 4 or 5 crops, and the amount of returns which we get is phenomenal, because we are completely processing our produce, and we are marketing it through various cities. The in We are just last few slides, and what is more important for all of us to understand, it is the health of our soil, which actually leads to the health of our nation, and we owe this to the future generations to get this right. So this was a quote by Alan Brown, the Member of Parliament of UK. So this is by Nicky Horkoff, and where he told that without the magic carpet of soil, life would not exist on Earth, and the soil and life are twins. Neither can exist without each other. So 3 books from Robert Montgomery are must read. You can WhatsApp me, and I can help you with all these 3 reads. And he is a geologist by profession, and he was the one who actually wrote a lot of things on the Regenerative Act. And what his very famous quote is, "We need to embrace the idea of building soil biology and soil health. And these are the foundations for the future farming and the human life on Earth." So this is what we always tell, that the future of agriculture will come from people and small farmers, and not technology, from a new generation of farmers who embrace these small scale ecological nourishing and farming techniques. So this is by Jean Martin Fontier, and he is an advocate of ecological and sustainable agriculture. So what we want is each one of us should support our local farmers, and this is the what best I can share. Otherwise, if you look at whatever we do, we have maybe 10 hours of our workshops are usually for 8 to 10 hours, where we discuss each and everything from the plant physiology to the quorum sensing in insects. So I'm not a agriculture graduate, or I have no formal training in agriculture, but what I understood from the people who have helped me in this, I owe everything to them, and I thank Dr. Ram sir, and to giving me an opportunity to help or show what we are doing in our very small scale 36-acre regenerative farm.
Thank
Thank you very
you,
much.
Dr. Prashant. I think that's wonderful to hear from you. And last time when I heard you, I thought all my team and the others should hear to see that it is possible on a scale as well. Otherwise, normally people think it's only possible in 1 acre, 2 acre kind of thing. And but on a scale, you could demonstrate. And also, it was very nice to hear from you on the basic concepts as well. I think that's really wonderful. Couple of questions which were coming up earlier from the participants and also from my own side so that the things become more clearer to the people. How about the economics of it? Because many times people
Yeah,
say it is very expensive. Yeah.
yeah. Though, sir, the economics, uh, I think it is quite economical. So when we started, because we are producing and we are marketing it ourselves, it is economically very, very viable. Uh, when we were doing conventional agriculture, even exporting our bananas, we would hardly get 1.5, 2 or 3 lakhs as a profit, 1.5 to 2 lakhs as a profit. I would share one. So I was in this uh, uh, our turmeric cultivation. So our turmeric, which we produced in 1 acre, it was an intercrop. We had about 18 quintals of turmeric produced. And we sold it from 300 rupees to 800 rupees per kilogram. And that was very economically viable. So when we would have sold it in the open market, we would have got maybe 70 or 80 rupees. But we were organic. We got it tested for all pesticides, herbicides, and insecticides, almost 700 of them. And there were not even a single trace found of those. And now we are selling it at about 800 rupees retail, and we have sold it in more than 30 countries. So this is, it has been very economical. And
Okay.
the profitability is also quite significant. We could have about 4.5 to 5 lakhs of profit from with, including all the expenses, with just a single turmeric crop. A total,
Okay.
yeah, the same thing happened with our chickpeas. So I'll tell you, a very interesting thing happened with the chickpeas this year. So the average yield from an acre, we got about 16 quintals per acre of chickpea. And we could process the whole thing into chickpea dal, and we processed into the atta, and we sold it between 250 to 400 rupees uh, across the country. And we actually made up about 3.5 lakhs from just a chickpea crop in an acre of land, and without any inputs. We had only once we had done manual de-weeding of that crop. The rest, there was no expense at all. And the harvesting and the planting. Apart from that, there were no chemicals sprayed, and it was only the biology which we uh, used through drip irrigation. The two, yeah, so that was the only manure. We use a lot of acetobacter, and all for legumes, we are using rhizobia. So there is no question of nitrogen, and otherwise our soils are very rich in potassium and the phosphorus. And the mixed micronutrient mixture, as I told you, sir, that we are
Yeah.
producing it at our farm. So we use fish amino acid, and we use almost a consortia of bacteria to break down those amino acids, and then we chelate them with these micronutrients: ferrous, zinc, manganese, magnesium, copper. And since they are sulfate salts, so automatically sulfur is also a part of them. And the
Added to
amino
it.
acids, yeah, those are the amino acids, they're all sulfur containing, most of them, 7 of them actually: cysteine, cysteine, phenylalanine, and tyrosine. These are all sulfur, histidine. They're all, they get chelated, and then we are using that. So our per liter cost of micronutrient is now about 10 or 12 rupees. Yeah,
Oh,
it's not,
nice.
yeah.
At very initial stages, when you are actually making the transition, did you suffer any yield loss or the transition was smoother?
No, it was very smooth, sir, because we started everything from the scratch. So there was a little bit of investment, because our teacher, Dr. Patil, who was helping me with all this, he said that whenever we start, we should do it with the bag. In the first 1.5 year, we could harvest guava, and
Oh,
this gave us, and then in the first year itself, we have our intercropping. First, we had a pigeon pea, which sold very well because we processed the whole thing, we packed it, and we marketed it across India on an online platform. So it helped
oh,
us very well, and we could actually get a huge amount of this produce. Small crops actually helped us for 4 months duration. Now this is a year where we are going to have major crops coming in, like sweet orange. We have custard apples, we have guava, we have mango, we have turmeric, we have ginger, almost more than 150 quintals of ginger we have planted this year. Then we have moringa. Almost we converted the whole farm into a syntropic intercultivated moringa. So we have mango, guava, moringa cultivated as a single farm. We are adding cocoa in that. So when we have multiple crops, obviously one crop makes up for the other. Last year, since the moringa prices were very high, it touched about 140 rupees per kilo. We had excellent yield of moringa. We have moringa powder, which we market at 1200 rupees per kilo. So this, when you have a value addition with your primary crop, and if you're able to market it, then obviously you are going to benefit. And now, seeing our success story, many farmers have started using our techniques. Some we are helping them into a vegetable market garden. Certain farmers, we now have our own 500-acre where we are producing aromatic herbs. Then we have moringa, we have vegetables, we have fruit crops, we have cotton, organic cotton. So there are so many things which can be done with all our regenerative farming techniques. I think it is the way to go forward. And with the equipments, we were able to cut down the labor cost, and our input cost significantly declined. We have hardly any input cost except for the labor now.
so in fact, that's another question I wanted to ask because another issue many people brought up is the labor problem. So both in terms of lack of skilled labor available and also the cost of labor increasing. So how do you see that?
Sir, what we have done is we have done a lot of mechanization in the farm. So for the earlier we were terminating our cover crops with this weed cutters and brush cutters. Now we have small tractors which can help us to terminate all these cover crops. And even because all our crops are on raised bed, only with good mulching, the amount of weed pressure is much lesser.
Okay.
So yeah, so with the only labor which we require is during the planting and harvesting and pruning. So these are the three activities where we require labor. Otherwise, uh, uh, last year the major labor requirement was during harvesting. So since
Yeah.
we are packing all our produce, everything is packed, processed using traditional methods. So we have that fixed 8 labor who does all the farm work, including the packing and and we have other people who take care of the distribution and shipping the products.
Okay. Uh, Before we continue with more questions, let me also ask the participants if they have questions. Anyone who want to ask any question to Dr. Rajput, can you raise? Anyone in the participants?
The participants can raise their hand and ask their questions.
Yeah, Jaydev, please. Jaydev Singh, please. Can you unmute and ask?
Yeah.
Yeah.
Okay. So, can you hear me now?
Yes. Can you also introduce yourself?
My name is Jaydev Singh. I'm based in Rajasthan, and I'm very much. I'll just start my video also. Thank you. Okay, I'm based in Jodhpur. I have a farm around 80 kilometers from my town, and I'm new to farming in the sense I've retired. I'm senior citizen, and I retired from corporate world, and now inherited some land which I'm trying to develop. And I'm very interested to develop it on the basis of regenerative natural farming. There are many terminologies, and I found it very fascinating what the doctor has mentioned. I think his knowledge on the subject is extremely. It's fantastic for a doctor to have that knowledge. He can become a expert agriculture consultant also. You see. But coming to the point, I'm very fascinated on one aspect of which I'd like to learn because I am basically doing field crops. So in my area, and I do it through contract farming. I have a farm of 65 acres, and there are three families who contract farmers who do it, and they're more familiar with agronomic field crops like mung and mustard. So for me to transition into orchards and all is not easy. And I like to stick with the traditional and but improve my productivity, which is the soil health which he mentioned. And I would like to request doctor because he's got a very complex and very sophisticated system of the organic biological liquids which he's preparing, Jeev Amrits and a lot of other things. I saw the visuals. So I would like to, on a separate session with doctor, if I can visit to get a first-hand knowledge of how to integrate all these, where I can use it on my farm through the drip system and to so that is something very fascinating for me, at least something where I can use or put organic inputs and improve the whether I'm able to do zero tillage or not. Maybe it's a different subject, but I'll be more interested on how to use these different type of liquids, bioliquids, and to improve the soil condition and sustain soil.
The I'll yeah, more than the liquids, what we found is beneficial is using cover crops. If you have cover crops and if you terminate those cover crops, and that is the major driver for improving soil fertility. So I believe that you have more of legumes and mustard and all those.
Yeah.
So basically oil seeds and so the agronomic practices are not very different. The only thing you can also do a no tillage in this. The only thing is the planting equipment will change. Okay, so you need to have a seed drill, and that should be enough to sow the seed within the soil. And you can use a sprinkler system as an irrigation method, especially if your crops are not very tall. If you're using it for mung or so, I can be very sure that your yield will significantly increase. So we have had a mung plantation this summer, and our yield was about 8 to 10 quintals, which has exceeded 8 to 10 quintals per acre of land. So this is only because of the improving soil fertility. We should, one very important thing is we should use a lot of these inputs, mainly using the cover crops. I think the cover crop is the key. If you're abusing the land, if you're
Okay.
frequently tilling it, your fertility goes down. So
Yeah.
minimizing tillage is the most important message I would like to give. Second is to have a living root. Always don't leave your soil bare anytime. Okay, there should always be some plant which is grown there, either be a cover crop
Okay.
or be a field crop.
Okay.
There is nothing called rest to the land. Okay, the land has always to be green, and it has to be covered all the time. The soil has to be covered. That's And once you have
So, doctor,
huge amount of biomass produced, if you're per acre biomass, so we were able to produce up to 5 to 10 tons of biomass every 6 months. Okay, so we have had some 6 cycles, and one of our field where we have recently checked the carbon levels, the percent organic carbon, it's about more than 9%. So your fertility can significantly return, especially when you are having a living root and when you have multiple cycles of cover crops grown. And obviously, once your organic carbon improves, your soil biology is very good. And once you have a functional soil food web, your yield can increase up to 200%.
thank you. Doctor, I want to ask you one more question. Soil testing, because the farm is located in an interior, and government testing is very laborious to go to a government lab, and we don't even know the accuracy of those. Is there any equipment you can recommend which I can use on the farm myself, and easy testing to keep checking the nutrient
See, I
composition of
think
my soil?
we are actually moved away from soil testing. Last 2 years, even in the United States, they have moved away from the conventional soil testing, because this only gives you an idea about mineral nutrition in the soil. But if you look at the plant, okay, the plant will consume nutrients not only in its ionic form. So there are organic ways by which the plants can take up nutrients. They can take up peptides. They can take up free or organic form of phosphorus. They can take up free fatty acids directly through the roots, which are the products of the microbes. So what we are actually in process of getting those equipments. There's a test which is called as a Haney's test, and the equipment is called as a Solvita. So basically, it measures the amount of carbon dioxide released from the soil. It's a measure of the microbial content of the soil. So we have actually moved in from the mineral, measuring the mineral content of the soil, and we try to now look more on the biology part rather than chemistry and the physical aspect of the soil. So what you saw, all those preparations we make, okay.
Yes.
So we make about 60 to 75,000 liters, and this we have completely eliminated use of any form of pesticide, any form of herbicide, any form of insecticide, any other amendments in the soil. And once we are giving so much biology in the soil has become disease suppressive. Okay, so because we are introducing IMO, we are introducing certain specific microbes. We are able to completely eliminate any form of harmful fungi. They have become disease suppressive. The plant immune system has become functional, and the amount of the pest pressure has significantly come down. So whenever you have an opportunity coming to Jalgaon, we will be very happy to help you. We can show you what we are doing, and we can give you a training also in
Okay.
making all those things. Yeah. So that is not a big thing.
Thank you,
So
doctor.
anytime
Thank you.
you can.
Thank you.
Thank you.
Mukesh,
Okay. Thank you very much, doctor. Thank you.
yeah. Mukesh, can you ask your question?
Yes, yes, Ram sir. Thank you.
Yeah.
So I work in the impact sector primarily with small farmers, and while working in the communities, my question is that when we are starting on this journey, this transition, and primarily when we are working like a soil to sale cycle, as Dr. Rajput was saying also, what would you recommend, sir, as the complete non-negotiables? As in, moving directly from 0 to 1 might not be a possibility. So, on this journey, when we start, what could be the sort of best way to approach it, step by step, if we are moving?
Yeah. So I think, see what has happened, we have also had a very gradual transition. Okay. We were mainly our primary crop was banana. And once we made that transition, we had a complete plan in mind how we are going to do about it. So planning is very, very important. And to begin all with all this, improving the soil fertility is the key. So once your soil fertility improves in the next 2 to 3 years to come, you're going to see a complete transition of the food. The food which you produce becomes so nutrient dense. People who are consuming, they will swear by you forever. So marketing of our produce after 2 years became very, very easy. So whoever has tasted our products anywhere across India or the globe, we had 100% people coming back. So that is the power of the soil. So when we have to transition, we have to work on soil fertility and bringing back fertility in the degraded agri system. So that is the key.
Thank you,
That's
sir.
really
Thank you.
good. Yeah. Santosh?
Yeah, thank you, sir. Yeah, Dr. Rajput, when we are transitioning, making a transition, and the main thing comes is market linkage. Yeah, the farmer who is situated nearby the urban market, they can access the market easily for value-added products and the fresh products. So how can we replicate this model to smallholder farmers who is located as like in an isolated location?
I think this has to be done to FPOs and FPCs. Okay, it is very difficult for the individual farmer to do that. So when we started it as a small farm, and now we are a group of now 12 farmers on a 500-acre model, and this will be one of its kind. We are already into our one of our FPO is already into export of bananas. So we do 6 containers per day of banana exports. Okay, so we were initially this in the lockdown. That lockdown actually gave us a lot of time. Apart from seeing COVID patients, we had a lot of time doing all this, and doing market research. We took help of a few of my friends who were in IIM Calcutta, and building up brands and branding it. And now, um, since now we have a fixed uh, clientele, it is which is expanding every day. So through FPOs and FPCs, it becomes very good. So small farmers should get together, and they should uh, work around. And definitely your agency and sir is doing so good work for small and marginal farmers. I think the key is to uh, brand your products. So if you are unique, and if you're able to brand it, and I think everything sells here. This is India. India is a large market.
Yeah. Shall I ask Dr. Vasavi to share her experiences? Dr. Vasavi? Dr. Vasavi, are you there? Okay, let me come back again. So when we talk about field visits, etc., Dr. Rajput, what would be the ideal time to visit your farm? So there were many requests from the farmers and to visit from Maharashtra and also from other places. So what would be the ideal time?
Yeah, our farm is open for any and everybody, sir.
Okay.
Yeah. It is there all throughout the year. Anybody who wants to come, my manager and myself, we will interact.
Okay.
And,
Yeah.
So anybody who's willing to come, we have farmers regularly coming from Vidarbha. We have farmers from Madhya Pradesh and Gujarat also. So we have. And we are very open, so they can come see and they can learn the processes there.
Yeah, that's really good. And also properly documenting in terms of all the practices also may help if probably we can also help in the doing that, and then because so that it will be one good case study which people can do it. I think
yes,
we can
sir,
do that way.
We have documented everything.
Okay, so you have everything. Yeah.
Yes.
So probably you should put it out on your website then. It will be much easy to access
Yeah. So we
more
have documented each and every activity. Yes, sir.
Okay. That's nice. So that will be very useful for many other people to take it forward.
Yeah.
And
so the initial what we have now focused into is the profitability of farming.
Correct.
So the people have to be convinced that this is a profitable way to go.
Correct.
Now, seeing there's many people in our taluka, the tehsil which we are living, so they have at least reduced their inputs to more than 75%. And more and more focus is now going into soil health and the plant health as well. So since we do regular workshops for farmers, whenever I'm there, we have workshops on different aspects of farming, on plant physiology. We have on disease and pest management, on plant nutrition, and we have on cover crops. We have on regenerative practices, livestock, everything. We are trying to help farmers so that once they have that integrated knowledge, it can be used, and that will help them because once their soil fertility comes back, it's everything else follows.
Right. So Mahantesh, can you?
Yeah. Thank you. Good evening, Dr. Ram and Dr. Prashant. It's very good to hear. Yeah, it's good to hear from you about the regenerative farming. See, I run an academy on agriculture, Aaranya Crops Academy. We are into connecting farmers with the new technologies, new technocrats, new ideas. Okay, it's a connecting platform. So when it comes to say convincing the farmer, because finally we have to bring the farmers on the board. It's a very tough job. Okay, in India. So generally, when you talk on regenerative, natural farming, organic, conservation, so on and so forth, generally the world seeks nowadays the quantified database of the effects of the farming. Okay, quality, yes, we can generate so many things, we can say so many principles, this happens, that happens, but generally when it comes to the traceability issue, or nowadays the style of living of the urban people, I'm saying, not on the rural folks, they do ask several things. Even in some of the institutions, they do ask the quantifiable units or the protocols. about this.
Yes.
Did you make any attempts towards that?
See, now what we are doing is we are now into mapping our nutraceutical concentrations in our farm produce. So this is way beyond what quantifiables in terms of nutrition, because ultimately whatever we are producing is food, fiber, and fuel in the farm. So they have to be quantified. Okay. So we are working with our fellow nephrologists in the US, okay, on certain proteins, on certain nutraceutical properties of the food and the gut microbiome. So we, when we are producing food through these natural systems, we are now able to show that there's a significant reduction in the inflammation, which is happening in people who are consuming it. So some of our patients who are consuming our products, we are regularly monitoring for their microbiome and the DNA fragments of the microbiome in the food as well as in the soil. So whatever food we are giving our patients, we regularly monitor them for inflammation, and we have tied up with a lab in France, which does the DNA mapping of these soil microbes present in the food. So this is the future, and one of our fellows in the US is working on argothionine, which is a very novel proteins which are found in vegetarian. It's a vegetarian protein in the legumes, and we through regenerative techniques we have now found that their highest concentration is when your organic carbon is more than 5. So in soils where we had planted this, where the organic carbon was more than 5%, 7%, 9%, the concentrations were proportionately higher. And this has made significant impact in small clinical trials, which we will be publishing very soon. So, and then once we have people and published literature of food in organic systems and then nutrient density, automatically you will have a large crowd of people who are willing to buy the produce and obviously sell the produce. We are not certified, nor we are trying to certify ourselves in by any of the agencies as of now. But what we are going to do is try to disseminate this knowledge of soil health, plant health, and human health. So my basic primary work is on human systems. Being a nephrologist and being a person who understands the functional immune systems. So we are now studying ways by which through regenerative farming, the plant immune system is behaving. I'll share one very interesting thing which we have observed is in last 1 year, we have not had even a single plant wilting in our farm without use of any fungicide. So, and this is the most important thing which I feel. And since we are working on inflammation, because of the kidney issue and the CKDU, I am also a part of the International Society of Nephrology, working on the CKDU project, where we are determining why people in agriculture are more likely to develop kidney-related issues and fatty liver. And that we have now found that the whole story comes out through the soil.
And is it pesticides or fertilizer residues?
It is weedicides, sir.
Weedicides, yeah.
Okay. So weedicide,
mostly,
yeah,
particularly glyphosate based.
Yeah,
is that the major
there,
culprit? And other also.
Most of others also.
Okay.
So they are altering your soil microbiome, and that is inducing inflammation in the gut, and that is leading to inflammatory diseases.
Okay. Dr. Rajput, do you have all 36 acres under irrigation, or you have rain-fed area as well?
No, sir. 100% irrigation.
100% irrigated. Okay.
Yeah.
So assured rainfall is there. Water supply is there. Okay.
Yeah. So I had 100% of my land under drip irrigation in 1990.
Okay.
That was long back.
Okay. And you are continuing with that.
Yeah.
Dr. Vasavi, any more questions? And you also, can you share your experiences as well? Yeah. Yeah. Dr. Vas.
It seems she's on a call. So
Okay.
proceed, yeah.
Dr. Vasavi is an independent researcher having a long experience in working with farmers in Karnataka and a long-term friend.
Okay.
And she's also running a small experiment called Living Labs, where they are also trying out as a farm, training farmers and also growing regenerative farming in rain-fed areas. So
Okay.
she's a social science researcher, and she was part of various committees appointed by central and state governments on looking into the agrarian crisis and alternatives. So she works on agriculture policy related issues, and she also turned into farmer, and then she's also working directly.
Wonderful.
Any more questions from others? Yeah. Possibly a couple of questions from the participants which were asked earlier, and we just had a compilation of this. Did you had any time tested disease attacks, particularly when there were attacks in other areas in the nearby fields?
The first year, we had a millibug issue with the guava.
Okay.
Yeah. But subsequently, next year, suddenly there was no millibug. Nothing, not even a single millibug. I don't know why this happened or how it happened. But now we have no
So
major.
overall ecosystem restoration probably
Has taken care of that.
taken care, and also you have a lot of diversity in the farm. I think that also helps in terms of reducing the impact.
Pest burden. Yeah. And probably the functional immune system of the plants. We don't know because.
True. That's true. And also when there is the droughts, etc. So since you have irrigation support, it may not have an impact. But did you see the soil moisture levels increasing so that your irrigation requirement going down?
Sir, all of my farms, we have this IoT devices placed in the farm. Yeah. So we will irrigate only when your soil moisture levels in the primary and the secondary root zone is dangerously low. Otherwise, we don't irrigate. So this has helped us to save almost 70 to 80% of water requirement. Almost 3 days a week, all my irrigation equipment is, we only irrigate and fertilize. That's it. And we monitor the soil moisture, and accordingly only we will irrigate. In winter, the irrigation cycle, the irrigation cycles comes to very low.
Okay. Yeah, so that's really wonderful to listen.
So with my phone, I can do this sitting in my office. So which plot needs what irrigation? So based on the temperature and the transpo evaporation rate, and the humidity, we will decide how much to
You'll
irrigate
decide.
and how long. Yeah. But usually the moisture sensor will guide us the quantum of irrigation and the next cycle.
Yeah. And coming to the end, last question: how much you engage in the consumer education? Because I think it's one of the very important thing, and also being a medical doctor.
Yeah, we do a lot of work on in the community where we take lectures on food as medicine, because yeah, the consumer should know the exact way how the food was produced, and because of this, we have been able to have a regular. Even our local consumption is very high. So people who are aware of how we are producing food, obviously, even you would get convinced that once your soil fertility is so good, so your nutrient density of food is very high. And believe me, sir, whoever tasted our food, uh, produce whatever we are producing, we have had 100% sale of that. So we don't have
Okay.
any problems in selling, but we want to create more value addition on whatever we are growing now, so that we fetch a much better price.
One more last question. I'm curious to ask you about CKDU, because one of the places in Andhra Pradesh, you must be knowing,
Yes. We are
Uddanam.
aware of.
Yeah.
Uddan, yeah. So it's called
Uddanam.
Uddanam nephropathy. Yeah.
So Uddanam area has a severe CKDU problem. Uh, I'm sorry.
Yes, sir.
Yeah, I'm sorry. No, I'm asking about the CKDU problem, and particularly from Uddanam region, because when we discuss with other doctors and then many others, some dismiss the whole problem. But the problem is real. We are seeing it in the field. And
No. So it is
uh,
also published now that Udayam nephropathy, that because it is from the village, or the district in Andhra Pradesh where this nephropathy is in like epidemic proportions. So this is also seen in my place. So actually, the DW, the scroll actually made a video on this, because I was uh, in 2015, I had done a study in certain districts of Vidarbha, where the entire population were wiped off because of chronic kidney disease. From age of 6 to 70 years, 35% of the population had chronic kidney disease. And this part of Vidarbha were actually a cotton growing belt, and the amount of pesticide and herbicide use was also very, very high. So I was very sure that it was the problem related to the pesticide use and the herbicide use.
But this area in Andhra Pradesh doesn't use much of chemicals at all.
So yeah, so there may be basically it was also related to the environment.
Environment,
Yeah. So if you are working in hot, humid climates for long
it's a
hours
coastal
of the day,
area, basically. Yeah, it's a coastal.
Yeah, if it's a hot, humid climate, and if you're working for long hours, you develop something. It's also called as a Mesoamerican nephropathy, where you have repeated episodes of dehydration, and you develop an acute injury to the kidney, which because it is multiple and it is cyclical, you end up with losing kidney function at your middle age. Okay, so this is now a global phenomenon. It was also seen in Sri Lanka, and it's seen in Nicaragua and other Central American countries where it's a hot and humid climate. In Haiti is also a country where you're seeing this. So yeah, Udayam is there, but in our part where we are there, 100% it is linked to use of
Yes.
herbicides and pesticides. Even Sri Lanka, one of the researchers there, I can't recollect his name. He's in our meeting all the time, and they have actually shown that it was linked to a certain herbicide use, and that exposure was quite for a long time, and that led to CKDU. It was one of the reasons why Sri Lanka went organic.
I know,
Because
yeah.
of
I was associated with some of those groups. And in Vidarbha, you're right, because we also work in Vidarbha region in Yavatmal and Vardar and Amravati districts. And then we have seen high use of chemicals linked to many of the health-related issues, etc. So it will be very wonderful to catch up with you again on, particularly from a consumer education point of view, so that we can actually have a discussion with the more of consumers talking about why they should go for organic food and be responsible consumption. So that I think because more consumers shifts, more farmers will all automatically shift. I think that's something we need to figure out.
Maybe we can have one. I do a lot of presentations on it's called as my lecture is called as food as medicine. So how
we can do that actually? Yeah, we can do that. We can do that as a food as a medicine. I think that will be wonderful. And we also work with school children, and then we are trying to develop resource material for children. It will be very helpful to get some feedback from you on some of the materials we are trying to make on this. So if you have written anything about food as medicine for kids, school-going children, it will be very useful.
I have not written it, but I have
we
a
can
presentation ready. Yeah, I can write it. It is not.
Then we will work with you on that as well, because I think it will be very, very useful for kids. Because at that age, if they can understand what is wrong with the food they consume, and then if they can make change, I think it will be great.
Yeah, I'm doing it my son's school.
Okay, nice.
I do a lot of basically awareness activities for parents as well as children.
Very nice.
On
very nice.
on food and how you can improve your eating habits and improve human health.
Well, that's wonderful. That's wonderful to know. Thank you, Dr. Rajput, for joining us. And this is wonderful to listen to you. Your experiences gives us more confidence that this is possible and we can make it happen. Thank you all for the participants who have joined us. Next week, same time, we'll come back with another interesting session to share more experiences from the ground, so that we understand more about agroecology, farmers connecting to markets, and also the public policy related issues. Thank you very much. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.